Greetings once again and welcome to my new calculus channel. I'm John Gabriel and today we're going to look at the meaning of division and dividing fractions with numbers. So we've come this far up till lesson 4 where we saw how to get equivalent fractions, and now let's look at the meaning of division. So when we say that we're dividing a fraction p over q by r over s, what that means is that we measure the fraction pq using r over s as a unit. So let's see an example. 20 divided by 6 means 20 measured using 6 as unit. Okay, doesn't mean sharing 20 equally. Say for example you just had 1. How do you share anything amongst 1? 1 gets everything, doesn't it? So it's a stupid way of thinking about it, and that's the way they think about it in the mainstream math foundations. Very bad, very wrong, and it causes students to have a very superficial understanding of division, which hinders their further learning and progress in mathematics. So 20 divided by 6 means 20 measured using 6 as a unit. That means you need 3 sixes and 2 equal parts of 6 to measure 20. Okay, because that's 18 plus 2 is 20. So 3 units of 6 and 2 of 6 equal parts of 6 to measure 20. And we could also see this as the most primitive operation, which is difference. 20 minus 6 minus 6 minus 6 minus 2 means we've measured 20. So the following 3 examples, example 1 through 3 here, will show you how we use Euclid's proposition 12 of book 5 to find the answers to the problem. So if we want to divide 3 by 1, they already have the same denominator, so this is essentially a non-operation because it's just 3 over 1, which is 3, right? So, but in book 5 and proposition 12, what we do is we have this theorem that tells us if we just keep on adding the proportional antecedents and the proportional consequence, we'll get to the answer. And that's what this does. Similarly, the second example does the same thing, and it shows you that if you divide 3 by half, that you're going to get the same answer if you divide 2 by a third, because you're measuring with the reciprocal of 3 in this case and with the reciprocal of 2 in this case. That turns out to be multiplication. So in one lesson you've learned how to do division and multiplication, because multiplication is just reciprocal division. So in all these examples we see that if the fractions shared the same denominator, that the division would be a non-operation, as we saw in lesson 2. Remember, in lesson 2 when we adjusted our antecedents and our consequence, all we had to do was take this, make it the antecedent here, and take this antecedent and make it the consequent. And this ratio here is the division. Okay, that's the answer. And of course, to go from this to numbers, we would need to find a line segment which fits into these parts equally. And guess what comes into play there again? You guessed it, proposition 12 of book 5. And because that's so important, I'm going to show you how it's used. This is the proposition, okay? And it's very difficult to understand in this form. So being a genius, I've made it easy for you. And this is the proposition. It says that if you increase the antecedent, these lines will still be parallel. Okay, doesn't matter, right? See that? They're in proportion. Doesn't matter how you do it, and you use parallel lines to do it. Okay, so that is essentially the essence of Euclid's Elements Book 5 and Proposition 12. So what I've shown you in these 3 examples is the meaning of division and how to perform division using numbers or fractions. In the next lesson, I'm going to show you, by the way, how we can learn all the other interesting facts about fractions, things such as mixed fractions, proper fractions, etc., etc., and how to deal with them. So I just want to recap here because in our first example, we see that by simply counting in natural numbers, we perform division, right? How do we perform division when we count in natural numbers? We are measuring using the abstract unit. And then we notice that dividing by the reciprocal of a number is the same as multiplying by the number. That means P over 1 divided by 1 over Q is the same as P times Q. This was for example 2 and 3, where both answers are the same. That's multiplication. Okay? And so therefore both division and multiplication are measures that use a unit and its reciprocal respectively. In the next lesson, we'll learn more about fractions. Okay? So, if you're not already a subscriber, become a subscriber to my channel. Follow me on Academia.edu. Click like and tell your friends about this channel to come and subscribe and support me. Hope you've enjoyed this video, and there are 3 lessons left. The best is yet to come. I'm John Gabriel, and this is a new calculus channel. Till next time, goodbye.